In quantitative aptitude, so this video I explain you about complete information about decimal fractions. So we'll see all the shortcut methods and how to do calculation of decimal fractions and conversion of any recurring decimals, any repeating decimals into the fractions in shortcut methods, including all the problems, which is very important for the any competitive exams which will come in quantitative aptitude. So this 1 hour session, so I'll explain you almost around 15 to 20 methods for easy calculation tricks which are from decimal fractions. So first we'll see what is a fraction and decimal, right? So numbers, for example, for natural numbers, if we take now 2, so 2 I can write 2.0 also. So when a number is there with the decimal with some point, then we can treat it as a decimal number. Now 3.12, 6.001. So these are all the decimal numbers. Now these decimal numbers we can convert into the fractions, as well as fractions also we can convert into decimal numbers. Now in that mostly calculation oriented questions, 1 by 10, this is in fraction form. So in decimal form this we can write 0.1. So if you observe with an example, 1 divided by 10, so it is a 0, you take 0 and the point here. Now 10 ones are 10, so that is 0.1. If it is 1 by 100, so directly we can write 0.01. So if any fractions with the denominator are tens, 100, 1000, like this multiples of tens, 10, 100, 1000, so any number with some number and zeros, 100, 1000 and 10,000, only complete zeros are there except one, the remaining are zeros here. So here two zeros, so you can take after point there should be 2 digits. So this, because of these 2 zeros, the point should take to 2 steps backwards. That means 2 I can write 2.0. So if it is 2 by 100, that is equals to 2.0 by 100. So your denominator is 100. So because of denominator is 100, that point should take to the left side. So 2 steps should come forward. Up to here 1 step and 1 more step. So because of 2 zeros, we should take 2 steps. Now because of this no 0 and previous is 0.02. Now here is the point. So this point is transferred to this place. Should take the previous value. So 2.0 by 100 is 0.02. Similarly, 1 by 1000. 1 divided by 1000. So we can write before 1 we should take, so 1 is actually 1.0, that is 1.0 by 1000. So we can write as 0.001, because there should be 3 digits, because of the 3 zeros there should be 3 digits after point. So any number you can write like this. If it is 2 by 1000, then 2 by 10,000, 0.0030 zeros, and because of the 4 zeros again one more digit is 2, so 0.0002. If it is denominators are tens, 100, 1000 are there, we can use this method. Okay, 125 by 100, then denominator is having 2 zeros, so point should take to left, that is 1.25. 125 by 1000, 0.125. So how many zeros are there in denominator? That many digits should be after point, so that you can remember for conversion fraction to decimals with respect to denominator. Some tens, 100, 1000, 10,000, like these numbers are there. Then in decimals we'll see all one by one from addition, subtraction, multiplication, divisions. We'll see how to do addition in decimal numbers. So in throughout video I'll explain all the shortcuts. So starting just I'm explaining all the basics of decimal numbers. Then later we'll see the shortcut tricks in complete decimal fractions. So when you are doing addition of decimal numbers, okay, for example I'll take 0.234 plus 0.5 plus 0.0056 and plus 0.35 plus 3 is equals to dash. So this value you have to write in order. So vertical order you have to frame first. So when I am making now vertical order, first 0.234. Now under the point there should be point always. This is the main order you need to follow. Now you have 5 0. So 0.5 is the second. Now third one is 0.0056. 0.00 and 56. Okay, next the fourth is 0.35. 0.35. Next it is 3. So as I said 3 we can write 3.0 also. So any number is given after point we can just keep the zeros. These I need to add. So the empty places you can occupy with the zeros instead of confusing the problem. These are the gaps, right? This you can fill with the zeros because value will never change even if you add the zeros at ending for only decimal numbers. The empty places you can occupy with zeros, then you can do normal addition how you are doing like other numbers. This is 6, yeah, these are all zeros. Then 9, 8, 5, 2 plus 5 7, 7 plus 3 is 10, and 1 you keep 10. Then you can under the point again point should keep 3 plus 1 is 4. So 4.0896 is the sum of these decimal numbers. Similarly the subtraction of same decimal numbers. The question is subtract 3 minus 1.234. 3 is a natural number. 3 I can write 3.0. So 3 I can write as 3.0 minus 1.234. 1.234. So in this case the gaps which is their empty place you can fill with zeros. So you will not confuse. Now normal subtraction you can do it. 3000 and this is like 1234. Then 10 minus 4. So 0 minus 4 not you can subtract. Take 3. This is 2, 9, 9 and 10 when you do subtraction. 10 minus 4 is 6, 9 minus 3 is 6, 9 minus 2 is 7 and 2 minus 1 is 1. Sorry. So 1.766 is the subtraction of decimal. So same concept we can use for multiplication. Now how to do multiplication of the decimal numbers. Multiplications. Okay, I'll take one example. 0.07 into 0.006. The simple technique in decimal numbers multiplication is actually normal multiplication you do without seeing any point and without taking any zeros before number. So this is 0.07. So originally it is 7. 0.006. If you neglect the point, this value is 7 and this value 6. Now 7 into 6 is 42. Just write 42. 42 you can write, because without any point the value of this is 7 and value of this is 6. Now you can adjust the point. After point there are 2 digits, here after point there are 3 digits. Okay, for this 2 digits and for this 3 digits. So when you are multiplying you should add the digits. So total 2 plus 3, there are 5 digits overall after point. Now we also after point we should make 5 digits, but only 2 are there. So before that number you can adjust zeros. 0 you can keep like this. So 0.00042 is the product of 0.07 into 0.006. Let me take one more example. For example, so yeah, okay, for example 0.3 into 0.03, 0.003 into 3 is equal to dash. So if you neglect the point, the value of this is 3 and this is also 3 and this is also 3 and this is also 3 1. In case if you neglect the point, then just neglect the point and normal multiplication you do. 3 into 3 is 9, 9 3 is 27, 27 3 is 81. So that is 81. But after point, here there is one digit and here two digits and here is 3 and here is nothing. 3 means 3.0. So you not consider this. 1 plus 2 3, 3 plus 3 6. Total 6 digits should be after point. Now after point there are 6 digits. Only 2 are there. Then other 4 you can keep. Before also you can keep. So 0.000081 is the value of this. Only you have to count the number of digits after point and you can adjust the point. This is for multiplication. Now we'll see the division. Division in decimal numbers. Okay, 0 point example I'll take 0.0055 divided by 0.111. This value is how much? So here after point 4 digits, here after point 2 digits. If you write in order 0.0055 by 0.11. So for this, here after point there are 4 digits and here 2 digits. There should be digits should be equal after the point. Now if you observe clearly, here after point there are 4 are here. Here only 2. Because of only 2, just extra keep other 2 zeros. Now you just write the number without any point. 55 by 1100. So okay, arrange the points after decimal equal digits and remove the point. You can you can cancel it. 11 5s are 11 hundreds. So that is 5 by 100. So as I said before, 0.05. 5 by 100 is 0.05. Starting and external, same thing you can do it. In case numerator is bigger than denominator, Let us take one more example. If it is 0.72 divided by 0.00018, value how much? Now without after point, denominator is 5 digits. Here a number of digits 5, here a number of digits 2. So extra 3 we need to make. So 0.72, 0.00018. So there are 5 digits here, right? So you can keep 1, 2, 3, extra 3 zeros. Now this is 0.72000, 0.00018. Now both values are same. When you are doing division, just remove the point and write 72300 by 18. If you neglect the point, then you can go for normal cancellation. 9 table you can cut it, 9 twos are, and this also you can cancel it. So directly. So 9 table, or else you can cancel with 2 table onwards. That is 9 table you can cancel. So 8 are. Then 3 zeros. Again 8000 by 2, that is 4000. So make the number of digits same after point, then you can do the same process for normal divisions. Okay. So in divisions only, one other examples, like the question is asked 0.7 0.072 into 0.25 by 0.5 into 0.24. So like in this, observe now, here after point 0.072, 0.072. So here after point 3 digits and after point 2 digits. Denominator is after point 1 digit and after point 2 digits. Now if you count overall, in case if you count overall, for this 3 digits, 2 digits, 3 plus 2 is equal to 5, down is 1 digit, so after point 2 digits, 1 plus 2 is equals to 3, here 5, here 3. Now still extra plus 2 we need. Now you can arrange 2 more zeros in the denominator, so you should balance it. Just by observing question you can make it. Now I am keeping 1 0 here, just keeping one more 0 here. Now we can balance it. So finally, now this is plus 1 and plus 1, so 2 plus 3, 5, balanced it. Just you remove the point, without point you write the number now. So that number is starting is 72, 72 into 25 by 50 into 240. Okay, this you cancel, 25 ones are 25 twos, again 2 ones are 2 threes are 6, 1 carry 12, 36. Again normal cancellations, so 12 threes are 36, 12 twos are 24, 0, so 3 by 20. Then 3 by 20 is the value for this. We can do division. 3 divided by 20, 0.15 will get. Just you can do division. 3 by 20, put 0 point, 21 is 20, 10, put 0, 25 is 100, so 0.15. Make the number of digits equal and you can simplify this. Okay, let us take one simple example, one more. 0.75 into 0.072. by 0.18 into 1.5. So if you observe the number of digits after decimal, here is 2, here is 3, here 2, 1. So total is 5 above, here is 3 below. Now extra 2 zeros. Edges you can arrange. So I am keeping 1 0 here, 1 0 here. Then that becomes 75 into 72. Now don't consider the point when you are doing divisions. By 180 into 150. Without point, just consider and write. So go for cancellations. Okay, you can cancel with digits 25 3s are 25 6s are. That's 75 1s are 75 2s are. Right, again 2 table, 2 ones, 2 36. So 9 20s are 9 table, so 9 4s are 4 ones are 4 5s. That is 1 by 5. If you do division, 0 0.2. 0 0.2 is the value for this. So this method you can follow for divisions of decimal numbers. Now let us take the other type method. Okay, now if the problem is 0.795, the right question. This is altogether multiplication and addition together. 0.795 into 0.455 plus 0.545 into 0.795. So after observing question, we can have some clear idea. Here we need multiplying this both and multiplying this both. We should add. So there is a common term 0.795, and here also there is 0.795. So if you treat as this is some, like first one is A into B, this is some C, again this is some A only, both are same, right? So AB plus CA. If you take A common, B plus C. So from this both numbers, here and 0.795, 0.795. 0.795 you take common. 0.795 if I take common. Now here 0.455 plus 0.545. So 0.795 into, just to add this both. If you add both, you'll get directly 1.000. Then 1.000 is nothing but 1. 1 into something is the same thing. So 0.795 is the answer for this. Even additions or subtractions also similarly. Okay, if the question is okay, same type, one more question I'll write here. 0.985 into 0.125 minus 0.985 into 0.025. So by according to the question, we need to take the next step. So 0.985 is the common. So 0.125 minus 0.025. 0.985 into. So you can do subtraction this. That is 0.125 minus 0.025. 001.0. So this is 0.1. Now without point, just to multiply the number. Any time when you are going to multiply 985 into 1. Okay, without point there is 985, without point this is 1, so 985. Keep 985. If you observe now, here after point 3 digits, here after point 1 digit. Now 3 plus 1, 4 digits. We should leave 4 digits after point. So 1 2 3, one more 0 and point. Now there are after point there are 4 digits. So this is 0.0985 is the answer for this. Okay, now take one more. So this is one type, and you're coming to multiplication and addition or subtractions together. Now next method in decimal fractions. 0. Okay, right question. 0.46 whole square plus 0.35 square by 0.046 whole square plus 0.035 whole square. So like these problems I'll tell you in shortcut. So if you observe, here after 0.46, here after 0.046, so one digit extra here after point. Here 0.35, 0.035, so one digit extra. Now this one, so I'll explain you two methods. First, if you do normal like process according to the operations of mathematics, 0.46 square is numerator, 0.35 square as same thing, by this one. If I split 0.1 into 0.46 whole square, see 0.046 is nothing but 0.1 into 0.46 plus this also 0.1 into 0.35 whole square. So if you take the 0.1 common in the denominator, 0.46 whole square plus 0.35 whole square by, take 0.1 whole square common. So for this square and this also square, then 0.46 whole square plus 0.35 whole square. Okay, this numerator and this is cancelled. Then 1 by 0.1 whole square, that is 1 by 0.1 into 0.1, that is 100. Because after point 1 digit, after point 1 digit, total 2 digits in denominators, so we can write 100. Or else this is nothing but 1 by 0.01, so that is 100. 0.1 into 0.1 is 0.01. 0.1 by 0.01 is 100. Now such type of questions directly we can take the extra how much is there, that much you can apply. Okay, I'll show you one more question similar. If you take one question here, same like previous, let me write here 0.25 whole cube plus 0.034 whole cube. So if the base is same, this method you can apply. 0.025 whole cube, 0.0034 whole cube. Okay, now 0 point extra, this 0 and extra, so one more digit is extra. So this we can write directly 1 by 0.1 whole cube. 1 by 0.1 whole cube is 0.20 extra 1 because total 3 digits, that is 1000, become 1000. Extra how much is there, that much you can take. This you can directly for shortcut trick. Okay, in case the numerator is smaller, now here denominator is smaller, now in case numerator is smaller, how will do? This is one example of second one, 0.23. All right, question. 0.23 whole square plus 0.34 whole square by 0.46 whole square plus 0.68 whole square. Now previous problem is into 0. That is actually 0.1 is multiplied for this into 0.1, but this into 2 is this. Okay, 0.23 into 2 is 0.46. Okay, if you observe clearly, previous one 0.25 into 0.1 is equal to 0.025. So this is 0.1, but now 0.23 into 2 is equal to 0.46. So into 2, because of into 2 we can write 1 by 2 square, so 1 by 4, that is 0.25. Okay, how much is there, that much you can take. Numerator into dash is the denominator number. Similarly 0.34 into 2 is 0.68. So 1 by 2 we can take. Okay, let me write one more similarly. So you can check 2-3 examples, you'll get clear idea. Now 0.32 whole cube plus 0.33 whole cube by 0.064 whole cube plus 0.066 whole cube. So numerator into dash is equals to denominator, that we have to check. 0.32 into dash is equals to 0.064. Okay, here 3264, so compulsory we need 2 times, but extra 0.0 is there, so we also should take some point. Okay, now 0.2, now point will be increased, therefore 1 by 0.2 whole cube is our solution for this. 1 by 0.2 whole cube is 1 by 0.22 into 0.2 into 0.2, right? So 1 by 0. If you remove the point and multiply, 2 to the 4, 4 to the 8, but 3 digits overall, 1 plus 1 plus 1, 0.008. Now that is, we can take directly 8 into 1 by 0.2 cube, or 1000 by, just into multiply 1000 by 1000, 1000 by 8. Go for cancellations, 4, 500, 2, 250 and 125 finally. Okay, we can verify in this manner. I'll give last one more example for the same method. Okay, in this 0.27 whole cube plus 0.37 whole cube by 0.0027 power 3 plus 0.0037 whole cube. This value we need to find out. So as I explained, we should take the numerator of the value into dash. So 0.27 into dash is equals to 0.0027. Zero point zero zero two seven. Now what will come? Check it now. So this is same time 0.27 is there, 27 only. So compulsory 1 should be there. Now before after point there are 2 digits. So here 2 digits are there. So we can take 0.1, 0.27, 0.1, 0.0 because after point total 4 digits. 27 2 digits and 01 2 digits. 4 digits. 0.01. So we can write this is 1 by 0.01 whole cube. This is our solution. If you simplify 1 by 0.00, so actually we need to take after 1 6 zeros because 2 right. 1, this is nothing but after 1 1 2 3 4 5 6. So we can write in this way. Now I'll explain you. So these are the concept in decimals when you're doing divisions with the same numerator and with different denominators. Okay. Now I'll explain you how to find out the smallest or largest fraction. Smallest fraction or largest fraction, how to find out the given. Finding small fraction, smallest or largest fractions from the given. From given fractions, how to find out the smallest or largest. So I'll explain in simple shortcut. Okay, for example, given fractions are 2 by 3, 3 by 4, 3 by 5 and 5 by 7. So in this, what is the smallest and what is the largest? So there are two methods. One is we need to do division and one more. Okay, I'll explain you two methods, so which is easy for you that you can do. First, normal method I'll explain you. So normal means you need to go for divisions. 3 by 5, 2 divided by 3. Okay, the shortcut trick I'll tell you directly. To find out the smallest, first I'll tell you. The shortcut method is you can write first you take two fractions, 2 by 3 and 3 by 4. So 2 into 4 and 3 into 3. 2 4 is 8, 3 3 is 9. Take next second, third and fourth. 3 by 5, 5 by 7. 21 and 5 5 is a 25. Now in this smallest one is 8. In this both smallest is 21. Now 9 and 25 is the largest in two cases. Now we can take 8th value. 8 we got from 2 by 3. Now again 2 by 3 and 21 is 3 by 5. In this both you can do it. This into this 2 5s are 10 and 3 3s are 9. So finally this is the smallest. So 3 by 5 is the smallest fraction. 3 by 5 is the smallest. So largest is, we can take the larger values. Now the same question, 9 and 25 are the largest first cases. Now 9 is 3 by 4 and 5 by 7 we take. For largest 3 by 4 and 5 by 7. From this both, if you do cross multiplication, 3 7 is 21, the 20. So this is smallest and this is the largest. So 3 by 4 is the largest. So this is the largest and this is the smallest. So let me explain the similar question with the different method and two methods I'll see. To find out the smallest or largest fraction, or smallest or biggest fractions, find small and big. So both. I'll take the fractions 3 by 5, 7 by 9, 5 by 7, 9 by 11, 1 by 3. So here 5 are given. So when I will give the 5, now we can take normal division also, we can use this, which is the smallest or biggest. So if you do division each and every fraction, first to 3 divided by 5, 0.56 is 30. So this is 0.6, right? Now 7 divided by 9. This method also you can apply for smallest and largest. That is 0.0977, 63, again 7, 0, again it will continue. So 0.77, 5 by 7, 5 divided by 7, put 0 on point, 7 7 is 49, 1 0 7 1 is 7, 0.71 it is. 9 by 11, 9 divided by 11, 0.118 are 88, 2. So this is 0.8, keep 0 means 1, 0.81, 1 by 3, 1 divided by 3, 0.33 is a 9, 0 again 33 is a 9, 0.33. So this is the one of the method. When the fractions are simple, we can use this. Now from this data we can say which is the smallest, biggest. This 0.6, this 0.7, 0.77, 71, 81, 0.33. So obviously this is the smallest. Now this is a small value. 1 by 3 is small among the given fractions, and 0.81, this is the largest among the given data. So this is also one of the method. By division also we can do, and previous one is by doing cross multiplication, taking 2 set also we can do this, a shortcut trick according to the problems. So this method even you can use for ascending and descending order also. For example, the given fraction they're asking ascending order. Ascending order is small to big. Small to big is ascending order. Now same problem in ascending order is the smallest is 1 by 3, next small, so small to big, then 3 by 5 because 0.6, Next 0.7771. So 71 is small. Then 5 by 7, 7 by 9, and largest is 9 by 11. So this is the ascending order. Then descending order. So descending order is biggest, largest small. So big to small. That means we can write in reverse. 9 by 11 is largest, then 7 by 9, 5 by 7, 3 by 5, and 1 by 3. So this is the method you can follow for largest or smallest to take values. Okay, next. So these events higher to lower and lower to higher. So ascending and descending order concept you can use based on these divisions as well as making the fractions in order. Now I'll give some more questions from this fractions. If root 3 is equals to 1.732, then what is the value of 1 by root 3? Then 1 by 1.732, you should stop taking that. So simple shortcut trick for this, 1 by root 3 value we need to find out. So 1 by root 3, just multiply root 3 by root 3. 1 into root 3 is root 3, and root 3 into root 3 is root 3 whole square. So square root cancel, root 3 by 3. Now root 3 is 1.732 by 3. Therefore you can do division this. 17 decimal numbers. 1.732 divided by 3. So 0.735 is 15 you can take. 2, 3. 21 to 2. 7 again 21. So approximately 0.577. So division with the natural numbers is easy. Instead of dividing with the decimal numbers, we can make the problem simple and we can do calculation. Okay, similar sum one more in this. If root 3 and root 2 values are given, for example, root 3 is 1.732 and root 2 is 1.414. Then 1 by root 3 plus root 2 is equals to dash. So therefore now the given question only we can adjust 1 by root 3 plus root 2. You rationalize denominator. That is root 3 minus root 2 by root 3 minus root 2. With this opposite sign multiply and divide. Therefore root 3 minus root 2 in numerator. This into this and this into this. This a plus b into a minus b formula. Okay, a plus b into a minus b, a square minus b square. That is root 3 whole square minus root 2 whole square. So root 3 is 1.732 minus root 2 is 1.414. Square root cancel, square root cancel. So 3 minus 2, that is 1. So from 1.732, 1.414 is subtract 0.318 by 1. So 0.318 is the answer for this. Okay, now similarly, root 15, square root of 15 is given. The value is 3.87. Then find the value of root 5 by 3. Root 5 by 3 value we need to find out. So if root 15 is given, so I need root 5 by 3. root 5 by 3. So to arrange this, you just multiply 3 by 3. Therefore, root 5 3s are 15 by 3 3s are 9. So root 15 by root 9. Root 15 is 3.87 by root 9 is 3. Then do division. So 1.29 you'll get it. And asking, you can adjust this type also. Okay, so now I'll explain the last concept in this, how to convert the repeating decimals into the fractions. Actually, same this topic I explained briefly. You can find in description there is a link. So if you click on that link, you'll see the how to convert repeating or non-repeating decimals into vulgar fractions, into the fractions, how to convert. So brief video, if you want, you can see that, and some I'll explain here also once again, but completely the briefly, if you want your complete video, if you'd like to see, then click on the description and see it. Now I'll also explain briefly here how to convert. So there's a formula I'll explain here. The question is, now this topic is converting repeating decimals, repeating decimals into fractions. Okay, in this there are two type of repeating decimals. One is example 1.2 bar, that is 1.222, same number repeat continuously, same digit. And one more type is multiple of digits. If it is 1.23 bar, so 1.232323 will repeat like this. Okay, any type of repeating decimals, or so they are non-terminating, they will not terminate. So these are the non-terminating decimals. These non-terminating decimals we can convert into fractions. I'll explain you one simple shortcut method for this. Any type of non-terminating decimals. The shortcut method. Now 1.23 bar. Okay, this is the question. 1.23 bar. For this is without point, without bar, you just write number first. That is 123, right? So observe carefully, 1.23 bar. Now without point and without bar, if you write the number, that is 123 minus, except the repeating decimals, remaining is 1. So non-repeating, the non-repeating is 1. Don't come to the decimal point in a numerator. Complete number without point, without bar, minus non-repeating number is 1, that is 1, by 10 to the power number of digits after decimal, this is 2. Number of decimals after, number of digits after decimal is 2, minus again 10 to the power number of digits after point which are non-recur. There are 0 because nothing is there, right? After point 2 3 both are repeating, so 10 to the power 0. Now this you can simplify. 123 minus 1 is equals to 122 by 100 minus 10 power 0 is 1. Any number power 0 is 1. So 122 by 100 minus 1 is 99. Now 122 by 99 is the answer for 1.23 bar. Let me take one more example. 2.312 2 bar. Here you can understand some more clearly because I took different number. So first step is without point, without bar, the number is 2312, right? Without point and without any bar, the number is 2312 minus non-repeating number is 23. Don't consider the point in the numerator place. So 2312 minus 23 by 10 to the power number of digits after point. After point number of digits are 3 minus 10 to the power again number of digits after point which are non-repeated. Non-repeated is only 1. That is only 1. So 2312 minus 23 by 10 power 3 minus 10 power 1. So from 2312 minus 23 subtract 12 minus 3 9 0 10 minus 2 is 8 2 1. Okay, 1289 by 10 power 3 is 1000. 1000 minus 10 after 1 1000 minus 10. 1289 by 990. This is the value. Okay, for more clarity I'll give one more example, explaining one more. Okay, the formula I'll write here now. Okay, I'm taking 0.23, bar is on 3. Now what we can take first step, the total number as it is we should take, that is 23. Total number without point or that bar. Now minus non-repeating number is 2 minus non-repeated number. Non-repeated number is only 2 by, so don't consider the point or bar anything, by 10 to the power number of digits after point, only after decimal there are 2. 10 to the power number of digits after decimal minus again 10 to the power number of digits after point but non-recur. Non-recur is only 1, that is 2. Only 1 is there. Number of digits after point number of digits after point which do not recur. Recurring means they not repeat. So 23 minus 2 is 21 by 10 power 2 minus 1 100, 10 power 1 is 1 10. 21 by 90. 21 by 90 if you simplify 3 table 3 7s are 330s, so 7 by 30. So can you check this now? 7 by 30, 7 divided by 30. If I do division I should get 0.23 bar. 3 bar is on 3. Put 0 and point. 32 is 60. 10. Again put 0. 33 is 90. 10. Again 0. 33 is 90. Right? So 0.2333 repeating. That we can write 0.23 bar. So any number we can use this concept for finding. So based on this they'll ask you different questions. So like find the value of 0.57 plus 0.43. So we can do separately the formula for both. This is 57 minus 0 by 10 to the power 2 minus 10 power 0. plus 43 minus 0 by 10 to the power 2 minus 10 power 0, because there is no non-recurring digits after point. So 57 by 99 plus 43 by 99, that is 100 by 99. So different questions, any question is, the concept is same, that formula is same, so nothing is different, everything is same here. Okay, so these are the important thing, and if you can see this topic briefly also, so more briefly, there's a link in description and there's a website also, so from that you can go through and you can see many more problems which are related to this topic, and I'll explain you some more description, decimal fractions problems in this website. You can see here www.foundationforiit.com. so this link is there in description also, so there is link, if you click in that link you'll directly redirect to this website. So there is some more problems which are related to the same topic and same aptitude. There's a PDF also is there, you can see other questions which I not explained here, and from ICSE, CBSE, SSE intermediate questions and the material also is available in this website. So you please subscribe this channel, because this channel is only will upload videos which are related to the educational and which are related to the only aptitude and quantitative aptitude, and complete information from 6th class to intermediate, including IIT, MCET, JEE. Okay, I hope you understood well, and please anything is there, if you want any more problems or any more shortcuts, please do a comment in the description box, we'll answer for this. I hope you understood well, and thank you very much for watching this video.